Great. Can anyone hear me okay? Is it working? Okay, great. So I'm going to talk about a couple of things. I'm going to talk about, firstly, the project I run, which is Raspberry Pi for Beginners, and then I'm going to talk a little bit about a new project I'm working on, which is something slightly related to my work, and possibly a little bit of evangelising about Pi. So, my name is Matthew Manning, and I run a YouTube channel called Raspberry Pi for Beginners. I started running this back in May last year. After a bit of an injury, I had loads of spare time on my hands, and I had my Pi arrive around the same time. Since then, I've managed to accrue about 21,000 subscribers, and I've hit the 1 million view count on my highlights. So it's been going really well. It's been far more successful than I hoped it would be. When I started the channel, I started looking through a few tutorials online around the Pi to think if it was even worth doing, and I noticed a couple of things, so a few trends. The first trend was that most tutorials generally assumed there was previous knowledge of the users or the reader, and ultimately what that meant was that people would probably get halfway through a tutorial and find that they couldn't complete it, and the comments were often the same kind of questions over and over and over again on the tutorials. Also, lots of tutorials assume that the reader is at the same technical ability as them. So if you've got some incredibly intelligent person who's been a programmer for years, they may just gloss over things that are actually incredibly critical for your sort of beginner user. I also believe that videos are a fantastic format for people to learn from. It's the closest thing we have to teaching that we can get from a distance, and you can sort of somehow ask questions through comments fields and sort of get back to your users quite easily. Now, I've run into a few problems since running the channell. First of all, the Raspbian's come along and the GPIO library in Python keep updating, and that can mean that my videos get out of date, much to the upset of the people who watch it. Again, you have that same problem with the same questions being asked over and over again, so it's difficult to try and keep your videos up to date and current. It's very time consuming, so I can't produce half as many videos as I have ideas. And it can be very difficult to provide code examples. So if you've got something and you say, here's a baseline, you may want to work from this, it's very difficult via YouTube to present that code to people. So to solve that, I got contacted by a couple of lads from Canada who wanted to start a blog up, and they wanted to use my videos as the basis to convert all of my videos into text-based tutorials, making it easier for us to hand over code, and also to have text-based tutorials for slower paced. As you might notice, I speak quite fast and I can't stop that in my videos either. So if you want to have a look and you want to search through, most of the tutorials are on there. However, most of them are only the links to the videos. They're quite blank because, again, it's incredibly time consuming to write all those videos up. And there's just an example of what one of them looks like. So most of my demographic, you'll notice, is 96.4% men and less than 4% women. And there's something we want to improve. So if there's any dads with daughters in here, you should be bringing them along. Hopefully they should be learning and making them interested in this. It's most popular in the UK, US, and Germany. However, I have noticed there are some weird countries in there, not weird countries, but some unusual places like Mongolia, I think was on there once, so that's a lot lower down in there. So I've created over 60 videos in total. The ones I'm happiest with and the ones that get the most views are, just to give you an example, a few examples, how to program using the GPIO, how to install and use the XBMC Media Center, how to install VNC for remote desktop, installing Apache, that's incredibly popular, turning your Pi into a web server. How to read external temperature sensors is also quite a good one. How to use a 2x16 LCD screen. The introduction to the Gertboard that we saw earlier. How to send text messages in your Pi, that's really popular for people to alert on things in their house out and about. Very basic commands for Linux for your starters. How to put your Raspberry Pi online, which talks a lot about port forwarding, how to get around your router, that type of thing. It's a very theoretical video, but it does get around all things for some of those users. How to back up your Pi, the Noob software, serial console server, two-factor authentication, which is something I'm going to use for this project, which is one most people should be looking at, I think. Now, during the process of creating the videos, I I saw all the chatter and all the evangelising, especially from Rob Bishop, who's actually from the Raspberry Pi Foundation, and he talks heavily about encouraging people to, children to get involved in programming, become a maker, develop and actually create things, because the UK's industry is incredibly important to everyone, and we want to see the next innovations coming as a UK product, and some of the things we've seen next door are a perfect example of that. But with the job and what I do, we've seen another problem that is similar, but it's not so much about making, but it's about maintaining. And what we've noticed is that, you know, technical skills are dropping within the UK. That there aren't people with networking, security, and Linux skills, you know, server administration, those types of skill sets coming in. And we're seeing a drop in standard of job applicants for the type of jobs that where I work we offer. Jobs are being outsourced. They're going to places like Australia and Canada and India, and we're seeing, you know, it's never as easy to deal with somebody who doesn't work in your time zone, doesn't speak fluent in your language, and we do think that it's incredibly important that we keep those technical skills in the UK, because our infrastructure of the UK relies so heavily on our ability to look after this type of technology. You know, and we see businesses could go out to, you know, could go bankrupt just because they couldn't get the firewall working or the website went down, and if we're having to rely on outsourced skills, you know, there could be some political upset that could just wipe out an entire section of technical support from our country. So we do want to make sure those skills are coming in. So what do I do for a day job? Well, I'm a senior security support engineer for a security distributor. We sell firewalls, antivirus products, and that type of thing. And we sell them to a lot of the larger companies in the UK, and they're called Computer Links. We offer security services to small and large companies. What we mean by that is we provide ethical hacking from the perimeter, so we'll try and break into customers' websites, take them down, break into their firewalls, see if we can access their emails, camera systems, anything we can get our hands on, for the whole point of protecting that UK business or worldwide global business to allow them to continue to function without disrupt from hackers. And security testing. So I've created this slightly very cheesy video just to hopefully demonstrate a little bit about the idea of this concept I came up with when I first got my Raspberry Pi, and just hopefully enjoy this for a couple of minutes. So I try to show there the serious side of what this device I'm creating is going to be. Basically, the Pi is an incredibly small form factor, and it can be used to sneak into a building. Now, in reality, you're never going to get into the large-scale data centres like that. You'd be caught by the security guards before you even got through the gates. But since actually designing this, there's been a few articles on the news recently. I just want to show you again a couple of minutes ago, just a clip from this thing, which basically demonstrates a real practical example of a similar device that has been deployed recently in a bank.
This is the branch of Santander which was targeted in what police have called an audacious plot by a gang that could have cost the bank millions. A bogus engineer attempted to fit a device called a keyboard video mouse switch, similar to this, to a computer inside the branch in southeast London. This is how the alleged scam may have worked. A keyboard video mouse switch is fitted to the network of computers in the branch. Connected to a remote PC, either through the internet or by Wi-Fi, it would enable the gang to download sensitive data and control the system from a safe distance to potentially make millions. They could divert money from other accounts into their own, or simply sell the highly sensitive information such as credit card details on the black market, or duplicate thousands of prepaid cash machine cards and access money from banks all over the world, as happened recently.
So that may seem far-fetched, but actually this happened. So they actually didn't get away with it, but these guys did, and this was yesterday. So they snuck into a branch at Barclays, they put in a KVM device, and they managed to steal £1.3 million of money. So the idea is, what can we do to help businesses protect against these types of threats? And also to encourage people that if they're not necessarily interested in programming, there is an interesting career in security testing, security services and that type of thing, which I love and I enjoy and I think is a great thing to go into. So the first thing I needed was a small computer that can be hidden inside a network, so we have our Raspberry Pi. Gives real-time feedback when being deployed. So I chose this particular panel here, which is a 2x16 LCD panel. This one's from Adafruit. It plugs straight directly on top of the Pi, and it gives you a visual display back, so you can actually, when you plug it in, you can view and see information straight back from it. It's also got some buttons on the front of it, so you can go through some navigation. If you have a problem getting the thing working, you can then sort of fix any problems without having to connect a keyboard, mouse, and display and that type of thing. And also, it needed full Linux capability to support all of our testing tools, so we can run all of our security hacks and stuff through a device. And the Pi Ferret idea came up from the idea that you put it in the building and it ferrets its way out of the network somehow. So that's what we have on the Ferret side, and on the other side we have another Pi waiting to receive the connection from our Ferret, and that one I used the Pi Bow and the Pi Glow as another visual representation to know that the connection has been made. So what do we actually do? So in a normal business environment, you'd have a corporate system with a firewall in place. You'd have a hacker on the internet, or maybe a security operative trying to help and pretend to be a hacker. Over the internet, that is the internet, it's all the blue. And they try to make an SSH connection to the firewall, and they're rejected because the firewall policy says no, we're not going to allow internal connections. So what we do with this is we take our Pi, and in a proper environment we should say to the sysadmin, take this, put it into your network, and we'll see what damage we can do, and we'll come back to you in a week and tell you what we've done, if you haven't seen it by things going wrong. We hide the Pi inside the actual network itself. That makes an SSH connection out. And this is where the clever bit happens. What it does, if I can remember exactly correctly, is it opens up an SSH connection from inside the building to your host at home. And what it will do is it will fix the source port of the connection that's made outbound. Now what that means is that when we look on the server side, we can see that that connection is open. And then what we can do is we can open a connection to our local host on the same port that it was connected. So that's a bit blow your mind a little, possibly for some people, probably perfectly mundane for others. And what it essentially means is that on the device that we have in our house or in our office, we can actually get command line access by opening up a tunnel through the original SSH tunnel. And why that's clever is because the second connection that goes into the building is hidden inside of the original one, the firewall cannot detect that connection coming in. And that's where the protection, sort of the jumping through the firewall actually happens. Now this could be used as a very simple tool for just gaining remote access to a building, for if you're just a sysadmin. But what we would do as a business is we would connect into that Pi, and then we would then start to launch attacks on that business because they've asked us to, and we can try and see what big damage we can do. So this is how I've actually implemented it. So the first thing I do is I've added into rc etc/etc/rc.local, which is a script that runs after all other scripts in the system will run, and it runs a boot up message. As this shows so that we know that the device is booted. And this will look like, very much like you saw in the video. Skip forward, there we go. So this will just say that the Pi's ready. That way you know that you don't have to plug a keyboard into it. Okay. And the next thing we'll do is there's a cron job that runs from here, and every minute it will try and establish that connection out to the server side. If it notices that the connection has already been made, it will just give up, and we basically get this prompt on the ferret side to show us that it's made the connection. There we go. And then for the point if it is being deployed as like a hacking device, if the sysadmin didn't want to alert his other admins and he wanted to test the kind of the social engineering part against his admins, are they any good? Would they notice a rogue device in their network? The thing does shut down, so it's not just blaring light out so that everyone can detect it straight away. And on the server side, a similar thing happens. We have the servers listening, and there's a cron job that runs every minute to see if that connection's been made. And if it does, it flashes the Pi glow. And I think the demonstration didn't show the Pi glow, so it kind of did. But so this is what the fast forward because. So they're, again, incredibly bright lights, but it flashes and spins. That will run every minute. So you could be sat there watching, waiting for your customer to connect their ferret up. Once it's connected, it will glow, and you know that you can start running your security test against that device. So the first thing I had to do was to automate it so that, because they run via cron, the scheduling jobs, I had to automate it, so I had to set those Pis up, give them SSH keys, which is what I was referencing in one of those videos. How to set up SSH keys. This is so that the Pi can connect and make an SSH connection using certificate keys to exchange for logging in, as opposed to using a password. And it means you don't have to remember a password because they're just stored on each other's Pis. Those keys are exchanged, and once that's done, we can run the automation. And then there's a simple script just called connect to ferret.sh. And then that looks a bit like this. So what we would do, so on our server side, we would just change them to the directory. You'll notice that it's called netferret here. That's because I realised that apparently netferret is already used from a search engine from 1999. Felt I probably shouldn't take it. It may not be in use anymore, but it is used by somebody somewhere. So that's just changing that directory, and I've decided not to do live videos because they'll go wrong. And then just simply run connect to ferret, and now you can see that we have an SSH connection on our ferret, which is inside the building, even though we're on our server side. So there are some obvious problems for anyone who's a firewall admin. First of all, any good firewall policy would not allow SSH directly out of the firewall. They would probably block that from their user base. Secondly, if there's a DHCP server, not a DHCP server running, it's going to be difficult for us to give the server an IP address. So one of the next iterations, I'm going to run it using a packet sniffer, TCP dump. It's going to listen for the traffic. It's going to identify what traffic you can see, which will be at the ARP level, and it would manually try, I've seen this ARP packet, therefore I'll give it this IP address, and continue to try and go through until it finds one that works. Other things we could do is we could hide SSH traffic over a HTTP or a HTTPS tunnel or connection. However, any half-decent web filtering product would probably block that. We could hide SSH over DNS, although it's incredibly slow. And again, the firewall might not allow access out to us as a DNS server. So at that point, you're kind of stuck. So do you give up? Do how do you get out the firewall and all this stuff stops us getting out as well as in? Well, the last ditch thing you could do is just stick a 3G dongle on it and just go over a normal phone network, and that way you could get your access. So that's it really. That's what I do, and that's the project I'm kind of working on at the moment. Has anybody got any questions at all? Nope, didn't think so. Thank you very much.